Welcome to Volume 1 of the films of Charles and Ray Eames. Before we show Powers of Ten and its companion piece, Rough Sketch for a Proposed Film dealing with the relative size of things in the universe, a brief introduction to the filmmakers and the films. Charles and Ray Eames are among the most important designers of the 20th century. In the early 40s, the Eameses were the first to be able to design and mass-produce molded plywood furniture with compound curves. In fact, their work came to the attention of the military early in World War II, and the Eameses were brought into the war effort to design molded plywood splints, stretchers, and airplane parts. The splints seen here in production. After the war, they continued their work in furniture design. To choose just 4 Eames furniture designs out of 100 spread across 4 decades, the LCM molded plywood chair, 1946, the molded plywood screen, 1946, the Eames lounge chair and ottoman, 1956, the chaise, 1968. In 1949, they built their own home as part of the Arts and Architecture magazine Case Study House program. They lived there the rest of their lives. The Eames house, as it is known today, is considered a classic of modern residential architecture. From 1943 to 1988, the home of the office of Charles and Ray Eames was this warehouse at 901 Washington Boulevard in Venice, California. Here, in addition to their furniture design, they wrote books, designed museum exhibitions, made films, created toys, and more. The achievements of Charles and Ray Eames are too numerous to offer a complete list here, and some, like Charles' incredible eye for photography, completely permeate the work. So a very few examples must suffice. The House of Cards, 1952, the India Report, 1958, the exhibition Mathematica, A World of Numbers and Beyond, 1961, Think, at the IBM Pavilion at the New York World's Fair, 1964. Development of a design for a national aquarium, 1966. Charles's Norton Lectures in Poetry in 1970 and 71. The Computer Perspective Exhibition, 1971. The Copernicus Exhibition, 1972. The Franklin and Jefferson Exhibition, 1975. In 1950, the Eameses made their first film, Traveling Boy. From that point on, throughout their work, the films are a constant thread, a valued tool for communicating, teaching, recording, celebrating. Charles died in 1978. Their last film was completed the next year. Ray died in 1988 as she was completing the process of closing the office and cataloging their films and stills for the Library of Congress. During their lives, they made over 85 short films on subjects from toy trains to the laws of physics, from sea creatures to the world of Franklin and Jefferson. It is this work we celebrate in this series, The Films of Charles and Ray Eames. Volume 1 contains 2 films, Powers of Ten, made in 1977, and probably the single best-known Eames film, together with its predecessor, Rough Sketch for a Proposed Film dealing with the relative size of things in the universe. As Ray said in her introduction to the Powers of Ten book, Charles learned from Eliel Saarinen the importance of looking at things from the next largest scale and the next smallest. This ability to look at problems from many levels, changing the frame of reference and thereby gaining new insights and solutions, was one of the Eameses' great gifts. Powers of Ten is that approach made film. Rough Sketch, made 9 years earlier, is exactly that, a trial run at Powers of Ten, a test of the technique as it would be realized later. And yet Rough Sketch is a marvelous film in its own right. First, Powers of Ten.
The picnic near the lakeside in Chicago is the start of a lazy afternoon, early one October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now, every 10 seconds, we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds, the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Powerboats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters. The distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1,000,000 meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the sun. Now the orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the sun, followed by the massive outer planets, swinging wide in their big orbits. That odd orbit belongs to Pluto. A fringe of a myriad comets too faint to see completes the solar system. Ten to the 14th. As the solar system shrinks to one bright point in the distance, our sun is plainly now only one among the stars. Looking back from here, we note 4 southern constellations, still much as they appear from the far side of the Earth. This square is 10 to the 16th meters, 1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now that even the background stars will appear to converge. At last, we pass the bright star Arcturus and some stars of the Dipper. Normal but quite unfamiliar stars and clouds of gas surround us as we traverse the Milky Way galaxy. Giant steps carry us into the outskirts of the galaxy. And as we pull away, we begin to see the great flat spiral facing us. The time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk. The 2 little satellite galaxies of our own are the Clouds of Magellan, 10 to the 22nd power, 1,000,000 light years. Groups of galaxies bring a new level of structure to the scene. Glowing points are no longer single stars, but whole galaxies of stars seen as one. We pass the big Virgo cluster of galaxies among many others, 100 million light years out. As we approach the limit of our vision, we pause to start back home. This lonely scene, the galaxies like dust, is what most of space looks like. This emptiness is normal. The richness of our own neighborhood is the exception. The trip back to the picnic on the lakefront will be a sped-up version, reducing the distance to the Earth's surface by 1 power of 10 every 2 seconds. In each 2 seconds, we will appear to cover 90% of the remaining distance back to Earth. Notice the alternation between great activity and relative inactivity, a rhythm that will continue all the way into our next goal, a proton in the nucleus of a carbon atom beneath the skin on the hand of the sleeping man at the picnic. Ten to the 9th meters, 10 to the 8th, 7, 6, 5, 4, 3, 2, 1. We are back at our starting point. We slow up at 1 meter, 10 to the 0 power. Now we reduce the distance to our final destination by 90% every 10 seconds, each step much smaller than the one before. At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand. In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Skin layers vanish in turn. An outer layer of cells, felty collagen. The capillary containing red blood cells and a roughly lymphocyte. We enter the white cell. Among its vital organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man in the coiled coils of DNA. As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of the powerful genetic message. At the atomic scale, the interplay of form and motion becomes more visible. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. Now we come upon the 2 inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus, so massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom, atoms bonded into every molecule out to the farthest galaxy. As a single proton fills our scene, we reach the edge of present understanding. Are these some quarks at intense interaction? Our journey has taken us through 40 powers of 10. If now the field is 1 unit, then when we saw many clusters of galaxies together, it was 10 to the 40th, or 1 and 40 zeros.
We begin with a scene 1 meter wide, which we view from just 1 meter away. The sleeping man is having a picnic on a Miami golf course. As we back off, the clocks start, and we accelerate in such a way that after 10 seconds have elapsed, we will be exactly 10 times farther away. Now the scene is 10 meters wide, and in 10 seconds it will be 10 times that wide. The sleeping man is still in the center and will remain there long after he is lost to sight. After the second 10 seconds, the square we see is 100 meters wide, the distance a man can run in 10 seconds. Now a kilometer, 1,000 meters, the distance a racing car can drive in 10 seconds. The picnic is about lost as we begin to see Miami Beach. 10 to the 4th power, 10,000 meters, the distance a supersonic aeroplane can travel in 10 seconds. 10 to the 5th power, a 1 and 5 zeros, the distance a satellite in orbit can cover in 10 seconds. Our speed is growing at a tremendous rate. In these past 10 seconds, we will have covered almost 1 million meters. The Earth, that will be all but gone in about 20 seconds, looks solid and imposing and remarkably spherical. 10 to the 7th. Our speed is now about 2 million miles an hour, 0.3% of the speed of light, and growing fast. A beam of light on the same plane as Earth would travel this far in 1 second. We can now see the orbital path of the Moon around the Earth. As our speed gets to be a substantial percentage of the speed of light, it has an effect on our time scale. What seems a normal 10 seconds to us would be a much longer period in relative Earth time. Our clocks are getting out of synchronization. Now a long time elapses on Earth for each 10 seconds of our traveling time. The clock is spinning round. The light from the Sun appears, and parts of the orbit paths of some of the planets, Mercury, Venus, Earth, and Mars. 10 to the 12th. Considerably farther away is the outer group of planets, so that we now see our whole solar system. Because they are so much farther away from us than the Sun is, the stars seem to stand still. The entire solar system can now only be identified as light from the Sun. The ancient constellations demonstrate the direction in which we are traveling, perpendicular to the plane of the Milky Way galaxy. A supernova, an exploding star, flares. We are now 1 light year away, 10 to the 16th meters. We are approaching the distance of the closest star to the Sun, Alpha Centauri. Now our speed is so great that even the stars in the background slowly seem to change their position, converging to the center. The closest stars form a local group which gives another dimension to the sky. 10 to the 18th. As we back into the nebulous material of the Milky Way, we lose all familiarity with our surroundings. Gases and small stars of different kinds surround us. Now we are beginning to see the tremendous cosmic form of the Milky Way galaxy, of which the Earth is such a tiny and insignificant part. All the stars we see from Earth belong to this one galaxy, which in turn belongs to its local group of galaxies. These form part of a grouping system, much as the stars do. They are so many and so varied that from this distance they appear like the stars from Earth, although of course each spot of light now contains many millions of stars. Were we to continue our journey, the scene would probably now remain much the same. The spots of light might just get smaller. The trip back to the picnic on the golf course will be a sped-up reverse version, reducing the distance to the Earth's surface by 1 magnitude every 2 seconds. Every 2 seconds we will appear to cover 90% of the distance back to Earth. We notice the rhythm of change between periods of great activity and relative inactivity that will continue all the way down to our next target, the nucleus of a carbon atom just beneath the skin on the hand of the sleeping man at the picnic. Ten to the 9th meters, and to the 8th, 7, 6, 5, 4, 3, 2, 1. We are back at our starting point, and now slow up on 10 centimeters, 10 to the -1 meters. Again, in each 10 seconds, we will cover 1 magnitude of change. 10 to the -2 meters, 1 centimeter, coming in on 1 millimeter. The surface of the skin looks rough and furrowed. The outside layer contains dead cells which we constantly shed and replace from within. Within the skin, the dark area we see is a tiny blood vessel, a capillary. The blood it carries is made up of different types of single cells. This cell is a leukocyte. It is self-reproducing and one of those which contains in its nucleus all the genetic material, the 23 pairs of chromosomes that humans carry. The scene is now 1 micron wide, 1/1,000,000th of a meter. Chromosomes appear to be made up of donut-shaped parts strung together. Within the chromosomes we find the genes. Each gene contains endless spirals of stringy material, deoxyribonucleic acid, DNA. The DNA structure contains all the hereditary information. At this scale, we build models to represent the form of the atom from information about the components, their size, and movements. This is a single carbon atom. Carbon atoms are present in every living thing. An outer shell is defined by the orbital path of 4 spinning electrons, 1 angstrom. Passing through this shell, we see an inner shell, 2 electrons orbiting to prescribe a sphere. Within the second electron layer, we find what seems like a vast nothing. In each 10 seconds, we still cover 90% of the remaining distance to the center. Finally, it begins to appear, that unimaginably dense nucleus of a carbon atom, 12 orbiting parts, 6 protons and 6 neutrons. Our galaxy is 36 powers of 10 larger than the nucleus of a carbon atom. If the diameter of the atomic nucleus were a unit 1, then the diameter of the galaxy in atomic units would be 10 to the 35th, or 1 and 36 zeros.